So this afternoon we are starting with a topic more affordable, more modern aircraft. I should have a presentation coming just to, thank you, to illustrate the topic, and then I will give the floor to our colleague. I believe we have a very nice panel today, and I will introduce the people one by one afterward. Well, I come back in 1970 when I started to fly. Yes, don't look at me. I'm quite old. And at that time, that was my first car. I was very proud, by the way, very modern, cost-effective. All my friends were jealous that I could buy this used car. And okay, that was 1970. At the same time, my parents finally got a telephone. Wow, the top of the technology. That was really superb. And then finally, I could go to the Aero Club and take a first flight. First airplane I was flying in 1970. Well, that was really absolutely modern. A lot of equipment. They had a system on board. Automatic direction finding, ADF. Wow. We could turn something, find a direction. Crazy. Huh? You don't need a map anymore. You can use this ADF to navigate. Wonderful. So that was my young time. Well, today, this is the car of my daughter. Looks good, extremely safe. This is my smartphone. Well, it's an EASA smartphone, very nice, an iPhone. I like it very much. Well, but what we could ask a question: what went wrong with the car and telephone industry? I mean, well, more seriously, the GA fleet, and I believe Pete is making an excellent presentation on that. It's in average 47 years old. I believe he mentioned 48. It's even worse than what I was believing. So we are not getting benefit from the recent safety requirements. We are still flying with FAR 23, Amendment 7, Amendment 12 aircraft. We talk about CN23, Amendment 5, FAR 23, Amendment 64, but who has ever flown a CS23 Amendment 5 aircraft? Of course, nobody, because. So would you buy this car today without seat belts, emitting a lot of CO2, without ABS, without ESP? Come on, apart if you want to be a collector and put the car in a museum. No, you would not buy this car for your daughter. You would be afraid. So today, you would buy this one, affordable, modern, 5-star at the crash test, low emission, low consumption. So this is a question we are going to debate this afternoon with a colleague. And I will leave the floor to Bruno Cervia first. He has spearheaded the research and development unit of Pilatus since 2009, member of the management, responsible for the development and airworthiness of all Pilatus aircraft. He heads up a multidisciplinary international team of some 400 specialists from all areas of aircraft development. He was finally appointed Deputy CEO in 2018. He joined the company 30 years ago, and prior to this appointment as a CEO, he was Vice President for Research and Development, and he took care of the development work on the PC-21. He is his position of head of department. Bruno, you have the floor.
Thank you, Dominique, and good afternoon to all of you. I really enjoyed the slides from Dominique. I think there is lots of truth in those pictures. However, what I am missing is the picture of the cockpit. if we would see the cockpit of the old Cessna 30 and 40 years ago compared to today's Cessna, you would notice an incredible development. Today you have displays technology in this cockpit, you have navigation means like GPS, you have ADS-B links, synthetic visions. So you have so many support features that increase safety in the current general aviation fleet that you didn't have at that time. Of course, we look at the figures afterwards, we have much more traffic, we have airspace issues, we have other issues, but if you look at the product, the intrinsic safety of the products today is by far higher than used to be years ago. Unfortunately, probably we are going overboard. What I mean with overboard, you notice that more and more gadgets come along because there is a marketing aspect. You want to have touch screens because you are used with your smartphone to touch screens, and in the general aviation market, the customer is prone to be captured or tired by all these gadgets. So the future there is to go toward a concept of dark cockpit and trying to provide the data that you really need when you need. Why? Because if you look at the statistics, the 99+% of the accident is due to human errors. You have controlled flight into terrain, and I shame myself that still happens. So the weak link has to be supported, and this is the pilot. So training, what happens if one of these gadgets doesn't work, is fundamental. In the past, there was much less different in the off-design conditions. Today, you have a huge gap between a functional product and a product which is not functioning. So off-design conditions have to be trained, and you need really to look at the device that provide you less information but more useful. So the constraint is, again, limited mental capacity of the human being. What about the exterior? We see the airframe. The airframe hasn't changed at all. Why that? I think one of the key issues is the lack of economy of scale in the general aviation. It's very fractionized, the market. Europe is fractionized. No, we have to think more global. We have really to look at selling a plane is not just producing it and writing a nice advertisement or a brochure. You need to invest on a distribution net without distributors. It's like with cars. Are you going to buy an American car that is not supported in your village? I don't think so. So you have to think globally, and the aircraft is only the product, but you have to think about the global life cycle cost and the service you have to provide. So providing a service facilitates an economy of scale. Technology-wise, yeah, we haven't had, in the last years, unfortunately, if you see, apart from the carbon fiber pre-preg that unfortunately I ended up, I had several bad experience of black metal design, which didn't support at the end either the cost nor the weight. We have to move ahead. There is a huge potential in the composite fibers if you use them as you should use. That means monolithic structures. So get away from hand-laminated and pre-preg and all these easy things because they are labor-intensive. Cost today is labor, is not materials. So labor has to be kept under control. That means innovation in the technologies, and you have now the possibility to do that, and also in the automation. Look at robotics. Now you have companies like ABB who are providing you these little robots that helps each single operator. We have really to design for automation. Design for robotics is the key. So you have, unfortunately, to do a step, get rid of the old products, and start from scratch the design, looking at automation in mind. And last but not least, parts. Yeah, it's with the machining, we have done huge steps. 5-axis machines today are affordable. You can automatize a lot. But 3D printing, technology, topology optimization, I mean, you can do a lot. We can see now with this topology optimization, and we are in the qualification process, you can design each part fit to purpose by reducing material, cost, and weight. So we have incredible technologies ahead of us. We are really in the finals to make sure they are qualified for fit to purpose. And I'm very confident that on the airframe we have really major steps in front of us. Last but not least, propulsion. I'm not the best in this forum. I have some colleagues of mine who are doing fantastic things with electrical aircraft, and they will show you and talk about it later. That's a huge step for technology. For short-range aircraft, training, GA, this is coming now. So that's really a fantastic thing. And I'm still dreaming to use it for longer range, for my class of aircraft, which would be really fantastic. Another thought, we optimize systems, we optimize airframe, and what about the system integration? What we are lacking in the industry today is the lack of standards for system integration. I was talking yesterday to Dominique, and he's playing. He has a major opportunity to upgrade his aircraft with new avionics. He's not doing it, not because of the cost of the avionics. He's not doing it because of the cost of the retrofit. And here I think we are lacking. We are too much working by ourselves in our nice compartment, and we do not talk to each other to standardize interfaces, data buses, and all the I/O you need for the cockpit, for instance. So that would increase the safety, because any old GA aircraft could upgrade to the latest standards. So we are really behind that, because we think in compartmental and we do not think global. That's why I see really a big future in front of us, but we need to team together. We need really to work together, improve the standards, work on the standards, and not at a single component level, single systems, but with a holistic approach. And last but not least, I would like to express my thought concerning certification. I heard this morning already certification burden. Certification is seen as a burden. Why? How can we reduce the cost of certification? How can we reduce the time to market? I think it's a short-term thought. I think that the authorities have lots of know-how. And the authorities today are working together. It's not like in the past. We could have simultaneous certifications. And they have so much experience. They have seen so many things that probably you haven't seen. You believe you know all, but that's a very strong assumption. I think you have always to keep your ear open and listen to the authorities. If you work with them at the beginning and use them as a sparring partner, you can leverage them at your advantage and not at your disadvantage. If you come with a product and you enter to an EASA door, FAA, and you ask them, I need to have certified within a year because I've promised to a customer or to my shareholder, then you have lost the game. It's like turning when you drive a car and you do a turn. You have to look at the end of the turn, not the beginning of the turn. And certification is not the end of the turn. Liability will hit you later on. There will be plenty of lawyers to prove that you could have done an additional test and show something that you haven't done. And then you will realize too late what you could have done ahead of the game. Thank you very much.
Thank you.
Thank you, Bruno. Thank you for this very positive message. And now I'll leave the floor to Pete Bunce. Pete is the president and CEO of GAMA. GAMA, since 2005, GAMA has a North American headquarters in Washington and a European Middle East headquarters in Brussels, in Belgium. So GAMA, Pete and GAMA staff travel worldwide, engaging regulators, policymakers, elected officials to promote GA and advance the interest of GAMA global membership of more than 100 airframe, avionics, engine and component manufacturers, as well as the world's leading business aviation maintenance, repair, and overall companies. So GAMA is an important player. Thank you for being with us. Pete, you have the floor.
Well, Patrick, thank you very much for getting us together again. Looking at what we did in Rome a few years ago and everything, and then seeing the size of this room and the progress that has made since then is really a tribute to all of us working together. So thanks a lot. What I want to do is just cover very quickly just some of the drivers that we have as we look at general aviation. And right now, I'm going to focus on piston aircraft. Of course, general aviation is much more broad than that. But if we look at the existing fleet, first of all, getting data is sometimes tough to get over here in Europe, and hopefully with the new basic regulation, we'll have a better chance to be able to aggregate the data here. But from what we've been able to compile, about 28,000 aircraft here in Europe in the piston category. But what we're delivering here in Europe is about 127 new aircraft a year. So if you try to extrapolate how long it's going to take to replace that fleet, unfortunately, Dominique's still going to be able to fly that 172 for an awful long time, unless we do something different. So if we look at what we produced over a long period of time, and I only took this out to 2010 because once after the Great Recession, we leveled off at around 1,000 aircraft, piston aircraft deliveries a year. But look at that great big bubble that we produced back around the late 70s and the 80s. Will we ever get back to that type of production if we're still producing piston aircraft, still producing old technology that was developed between World War I and World War II, almost 100 years ago? No, we're never going to get there. Can we ever get there if we are able to certify quickly electric and hybrid, autonomous type of vehicle operations, and start to employ modern technology and modern techniques like additive manufacturing, and just what Bruno was talking about with new abilities to do carbon fiber? We can get it to high production rates. But are we going to be able to put them in the hands of individual pilots and owners? That's questionable because of price point. So let's take another look here. Look what happened to cost of aircraft. If you just applied to the car model that Dominique was showing early on, and you applied standard inflation rates, you can see what the cost would be, but it's gone asymptotic. Why is that? Well, there's a lot of factors that play into that. We talked about labor. We've talked about cost, that a driver, one of them is liability. 60% of the fleet of piston aircraft in the world are delivered to the United States, about 23% here in Europe. We have an atrocious liability issue that we have to deal with over in the US. In fact, one of our companies that's based here in Europe was in court a couple weeks ago because I call them stupid pilot pet tricks. And as a pilot, we all make mistakes, but there was a guy who flew around for half an hour with a full boot of rudder in, and lo and behold, when he was coming back in, he ran out of gas because he trapped all the fuel out in the wing because he was flying totally uncoordinated for 30 minutes. And we have the company in court. Most likely, the company's going to lose because they go after the people with deep pockets, and you get a sympathetic jury there in front of a state court or a local court and everything, and we as manufacturers lose every time. That drives up cost. And some calculations are it's about a third of the cost. So if we look at what the production looks like, this is just total across the world in 2017, last year, in four-seat aircraft deliveries. You can see those numbers are anemic. And what's driving that? It is that liability cost, but there's a couple other factors that are involved there. So if we look at the drivers that are involved in producing aircraft, One of those, obviously, is certification costs. And I would agree with Bruno, as we go and apply a risk-based approach, and you get higher up into the higher levels of CS23 and into CS25, the rigor becomes more and more. But if you go and you take a product, a 2 to 4 place general aviation aircraft, and you apply such a rigid certification formula to them, you're driving up costs. And what happens? A company's got a burn rate the entire time that they're waiting to get certified. They've got to pay for engineers. They've got to have people on hand. And getting the type certificate's just the first step in the process. People don't realize getting a production certificate is even more difficult, because you have to produce aircraft 100 exactly the same way that you produced aircraft number 1. And then you've got continued airworthiness. So costs keep going up. So until you can start recouping those costs by putting product out the door, your burn rate is tremendous. So that drives up costs. So we have to go and work on speeding certification, which is all what CS23 is like. Bodwin really helped us tremendously in being able to develop that, and now the key will be for us to make sure it works, because we get the new CS23 rules working along with Part 23 and get the authorities working together. There is no reason why we should ever even have validation of Part 23 aircraft. And by 2020, we should, and Trevor and Dorenda have been working on this hard, we should be able to have what would be called mutual acceptance. You can't use that term in the United States, but a streamlined validation for anything that's produced in the Part 23 category, because the rules are essentially the same. And that's what we've been trying to work at. But let's look to the future. Andre was talking about what we have available to us in electric and hybrid propulsion. Ivo's been a leader in this, his company. But if we go and we spend all kinds of effort and time to make sure that a lithium-ion battery in a small aircraft in 1 in a billionth chance could ever light off, and we delay an ability to get these products into market, are we improving safety or are we hurting it? I would contend you we are doing tremendous damage to safety, because the sooner that we can get people to fly these types of aircraft, that we can go and do autonomous type of operations where somebody can push a button and it'll take me and land me to where I need to go if all of a sudden the engine quit. It calculates, it can figure out the terrain, it can figure out even time of day if we can put it down in a schoolyard or not. That's how advanced modern communications are, and we can do this. These vehicles talk to one another. They're trading off as they fly abilities for places that they can land. But if we spend all of our time figuring out the one chance that a lithium-ion battery is going to go and have thermal runaway, and spend all of our time and drive up costs, we'll never get there. I fly with a lithium-ion battery every day when I fly the experimental aircraft I produced. And one of the reasons why we have so many experimental aircraft produced in the United States is because the cost is so much less, because we don't have to go through certification. I think we had a comment earlier this morning that not everything needs to be certified. In fact, I was astounded. I heard that there was talk that this was going to have the software that goes into development for everybody that flies with these, every commercial pilot, every business aviation pilot, that we're looking over here to have to certify the software when this piece of junk iPad could never pass a certification test. Why would we ever do that? This type of technology saves lives. And what we're able to do right now, not only show real-time weather, I just had the weather up for back in DC. It's real-time weather right now, but now we can send pre-departure clearances. We are able to look at dynamic temporary flight rules, look at airspace, look at other traffic on that. And if we go and try to certify the software, we'll increase cost, not be able to refine or put out new software in a manner that makes it safer. So to apply a risk-based approach, we need to look at all of these factors carefully and think about what we're collectively doing in driving cost and taking new technology away from the operator. So with that, I think hopefully that'll stimulate some questions. I know my colleagues will be able to talk a few more things on it. Thank you.
So
So our next speaker is Robert Kremnitzer from Diamond. He has been working with Diamond for more than 10 years as head of the Office of Airworthiness, so he knows about certification. And he's also holder of a private pilot license, and Robert will share with us his thought about the future of general aviation and how to make aircraft more affordable. Thank you, Robert.
Thank you, Dominique. Hello, everybody. Yeah, we are just right in the segment that Pete pointed out a minute ago with the market of small piston engines and some more modern technologies. I'd like to just introduce, like, we as Diamond are a global company, a global operator, and I think even this is the European conference here. I think we have to look at the global scale, because this is where we can improve a lot. It's about global sales, it's about global numbers. We as Diamond having locations here in Austria, headquartered here in Austria. We are in Canada for the North American market and in China for the Chinese market. For the range of products, I'd like to take the opportunity to just to give you a view of our product range and where we are coming from. So we produce small two-seated airplanes, single engine, up to twin-engine airplanes, 7-seat, special mission airplanes, all the range, starting from supporting aero clubs in their operations, flight training, which is a big market for us, private pilots and special mission. So, where are we? The question was, how can we make more modern and affordable airplanes? I think the modern airplanes are already available. So we at Diamond, we use these modern carbon technologies that Bruno just mentioned. It's our core. We use them to produce very safe and rigid airframes. Dominique mentioned the old technology engines that are still used in the 1970s airplanes. We have modern combustion engines, electronically controlled, low emission, low fuel consumption. We use the modern avionics that Bruno mentioned already, or Pete mentioned, that's available. It's in the airplanes. And we use the easy-to-fly single-lever control, or really just modern ways to control the airplane, also something that Bruno mentioned before me. So I think the modern airplanes are available. I fully think that there is room for improvement with regard to the affordability. And also Diamond, there is technologies to come we have to prepare for. So this is, if I may mention it here, was just the first flight of a hybrid electric multi-engine airplane. This was done together with the Siemens AG, and thanks with the help of the Ministries of Transport of Austria and Germany, as well as the responsible research funding agencies for this. So this basically is Diamond's contribution into the future to get the new technologies into the market. Okay. It's gone. Thank you. So, no, sorry. So really, this was just, we are there with the modern airplanes. Now, what are the three main points? So make them more affordable. And to me, it's really, I can just echo what's been said. We have to make use of any economy of scale possibilities. We need to put more airplanes out there, then they become cheaper. We need to really have the possibility to switch production, use the global possibilities to switch production from one to the other place where it's just needed, where it's just cheaper, where it's just necessary. And we should not have to wait for a small change to be certified in the other part of the world before we can start producing it there. We need to get access to the global market. It's not only the traditional markets with Europe, with the USA as a traditional market, but also the smaller and non-developed markets are very important because they just bring numbers. It's all about the numbers in the end. We need to make use of mass production parts and mass production technologies because all those are, again, bringing down the price of the product. And we need a minimum time to market philosophy. We need to get out the new products. We need to get out the philosophy, the new systems, the new available gadgets, just to learn also from the feedback we get from the market. It might be a good idea, but if it really works, if it really helps, we need to get some feedback from the market. And again, it's reciprocal acceptance and direct acceptance in all the markets at the same time. This would be, I guess, the best for us. Thank you very much.
Thank you, Robert. So after the well-known and well-established manufacturer Diamond, we now move to newcomers, and we will start with Sonaca. With Carl Mengdehl, he's the co-founder of Sonaca Aircraft with Pierre Van Vetter. I believe Pierre is in the room as well. I don't know if you have heard about Sonaca. Sonaca is a large Belgian company involved in aerospace, design of aerostructure. It's a very large company. And one day, got a call from this company. I was at that time responsible for the DOA department at EASA. And they explained to me that they wanted to have a meeting because they wanted to open a new division, a small business, to certify a small aircraft and get a DOA. I was a bit surprised. I knew Sonaca. I visited the company before, but I was surprised to hear about this project. So we met together years ago, and they had a question about the best way to approach the problem. Should we go for a DOA? Do we really need a DOA? And so on. All these kind of questions. I said, okay, well, I gave them my opinion, some recommendation. So what I have learned in my career is that normally when you give recommendation to people, they don't listen to you. So, which is not a problem. In the case of Sonaca, they followed the recommendation. And in 3 years, they got a DOA, and in nearly 4 years, they got a TC for their aircraft. So it's quite a successful experience. And so Carl will explain a bit more about what they plan to do to bring new, modern, and affordable aircraft on the market.
Thank you, Dominique. And as Dominique explained, Sonaca was founded in 1930s as Cervia Aviation. It was a subsidiary of Cervia in England. And the company started to buy their own aircraft also. Then manufactured many aircraft under license for the Belgian Army, Belgian Air Force. Among them were more than 200 F-16 aircraft. And then started to work for large commercial planes like Airbus, and then Embraer, Dassault, Pilatus also. Doesn't work. Okay. And we are mostly manufacturing fuselage and wing parts, leading edges, flaps, fuselage sections, etc. And in 2015, we decided to also launch a new subsidiary that was dedicated to General Aviation, which was the initial market of Sonaca, simply to use the competencies of the group in a market that was left since many years. The cause, according to us, for the aging fleet is these three major points. These are the most important. The first is the cost of acquisition, because people would like, I'm sure, to buy new aircraft. The people who are using these 40-something years old aircraft in Europe, they would love to fly new planes, but most of the case they don't have enough money to buy it. And the cost of these new aircraft is also partly due to the cost of engine and avionics, which are very expensive. So, of course, as much as we can reduce these costs, then as much we will be able to renew the fleet. The design life also of these new aircraft is quite long, Usually, an aircraft that is certified can fly for 20 to 40 years. It's great for safety, but it slows the fleet renewal, and it's also a pain for the spare parts availability, because when you have, as an aircraft manufacturer, to provide parts for an aircraft that was manufactured 40 or 50 years ago, it's a big burden in terms of cost and industrial organization. And then the last point also is the adequation between the demand and the offer, because when you try to sell an aircraft to a flight school, for example, you shouldn't try to sell an aircraft that is too light or too fast or too touchy to control, because they are more interested in an aircraft that is safe and easy to fly at low speed rather than a Formula One. Next slide. I think we need to change the batteries. The consequences now. For me, the most important consequences of not being able to access to newer planes is the recent certification standards upgrade. And for example, in our case, we certified our aircraft in the VLA category, and the most recent change is the improved resistance to crash. If you use a VLA that was certified before the latest date, you don't have the requirement for rollover protection, which means that if the aircraft at some point has a problem during the landing, you have less chances to survive. The other advantage is also all the human-machine interface and the foolproof design, as you also mentioned. It's very important, and it's a domain where there has been big progress in the last years. Not only because of certification standard, but also because of know-how and knowledge of people that are involved in the design of the aircraft. And it comes through correct arrangement of instruments. It comes through usage of adequate colors or sound signals that are harmonized from one aircraft to the other. And if we take, for example, this illustration here, it's useless to mention the advantage to pass from a flight manual of 20 pages for the Cessna 150 to, for example, a Garmin G500 with all the information and data that are integrated in it and that directly accessible to the pilot. Our approach when we started the project 3 years ago was to have something that is oriented to the market using lean startup methodology and ask the questions to the customers, to the pilots, to the flight school operators, and propose some solutions, validate it, and then only start to develop the aircraft once we are sure that it answers to the market. And that's how we discovered that there was a gap on the market for flight schools where a good product was still to be provided to the market. So we focused on an aircraft that is easy to fly, that is safe, that is also demonstrative in stalls and spins, and that is developed to have a low cost of ownership over 15 or 20 years, because when you fly an aircraft and when you have to invest in it as an owner or a flight school, the cost of acquisition is 20%, and the cost of operation during 20 years is the 80% remaining. And that's why we decided also... Sorry, can we reduce the sound, please? No video. Okay, thank you. And that's why we decided to develop an aircraft that was able to do spins, for example, stalls, very safely, in an era where the tendency was rather to develop planes with fly-by-wire and air data computer and flight computers and everything to prevent an aircraft from stalling and spinning. But the reality is that most of these aircraft, which, for example, in the commercial market have these systems, are still able to fall down like a rock if the pilot does not fly it correctly. So it's important to train correctly the pilot for these kind of situations. Our product is not very innovative in the meaning that we do not use advanced materials. We do not use much carbon fiber, mostly aluminum. But it's mostly innovative because of the way we developed it, using a lot of numerical methods. We see here, for example, simulation of aerodynamics, structure, etc. And it's useful for the development, but also for the in-service life, because we now have a system where we can monitor live the stress and strength and lifespan of the aircraft in real time, and calculate at every second with a few sensors in the aircraft the remaining life of the aircraft in terms of structural and system life. For example, here it's a small animation where we can see the deformation of the wing. Everything is incorporated in a simple model to determine exactly the remaining potential of the airframe. And it can be used to increase the safety of the aircraft, because you can prevent failures by monitoring the aircraft health, because the standard maintenance program is determined for kind of normal use of the aircraft, but you never know exactly how each aircraft is used, and some people will use it correctly, some less correctly, I would say. Some will never respect the warm-up time of the engine, and you can increase this safety by adjusting the maintenance of each aircraft to the use that it is subject to. And you can also reduce the cost, of course, because if the aircraft is correctly flown, most of the time you do not need to do the full maintenance as you should do according to the maintenance program. So this is something on which we are working now. It's not yet ready for the market, but we are acquiring data on our first aircraft on it. And it's really something that we are working seriously, because it's a big advantage. Now, of course, the most important topic also is to have a strong industrialization and after-sale on your project, because that's how you will reduce cost, and that's how also you will ensure happy customers. And if the customers are happy, they will continue to buy the aircraft. It will improve the availability of the aircraft on the field, because an aircraft that doesn't fly does not bring money. So it's also a very important topic. Last topic, a general remark that we have. Working on the aircraft is not the only way to improve the safety in general aviation. It's also all the environment around the aircraft, the pilot, the airfield, the operations, the rules, the access to information. And since all aircraft will not be replaced tomorrow or next year even, because of the problems that we identified before, it's also important, I think, to work on tools and methods and everything that can improve everything around this aircraft, to be able to improve the safety while still flying the aircraft we have at the moment. And one of the improvement ideas we have is also something that joins the ideas that were mentioned this morning. That's a very long text, but can be simply summarized in a graphical version, which would be a kind of database that could be set up by the EASA to centralize the access to information and ease the task of the pilots to prepare his flight, to perform his flight, and to log all the data after the flight. Because improving the safety is not only setting up rules, but it's also understanding how people use the aircraft, what happens when something goes wrong, and all these data at the moment are not easy to access. And the same way that data to prepare a flight are not that easy to access in an era where just with a standard smartphone, you get data that is gathered about your life, about you, and you have data that is served on your phone without even asking for it. I think we should also apply this to general aviation. Thank you.
Thank you, Carl. And we continue with the startup with the newcomers, even more newcomer, with Arthur Leopold-Leger. He is the CEO and co-founder of the company Elixir Aircraft, a French company. They are actually starting the certification process of a new trainer. The previous one was an old metal, aluminum, traditional airframe structure. This one is totally different. It's all composite carbon fiber. Arthur is quite experienced because he contributed to the construction of more than 30 aircraft kit designed by Dinaero, a French kit builder. He's also a pilot, aircraft, ultralight glider, more than 1,000 hours flight experience. So he also took part in this Tour de France des jeunes pilotes. So Tour de France is an initiative from the FFA, and we have the president here of the FFA. And this is something you can do when you are 15 or 18 years old, and you learn a lot. So, Arthur, welcome.
Thank you, Dominique. Yes. So this aircraft is the Elixir, the aircraft we have been building for the last 3 years. So before going forward, I will just introduce myself a little bit. So I'm 33 years old. I'm the CEO and co-founder of Elixir Aircraft. But most of all, I've always been torn between two passions, everything that is flying and everything that is sailing. And on top of that, I'm a true competitor. If wherever I am in an aircraft or in a boat, I have to win. I have to be faster, better than the other one. So we will see that, as stated by André this morning, those two passions are very important because I've been able to see what the aviation needed since maybe 50 years and what the sailing industry was able to bring to the aviation industry. Which is what I'm going to present you now. So let's just shortly come back to the topic introduced by Dominique. Do we need more affordable, modern, and above all, safer aircraft? So I will try to answer to you if it is possible, why, and how Elixir is doing that. Yes. So to do that, I would like each and every one of us to get rid of all our engineering point of view or the regulator point of view and just put ourselves in the shoes of the random innocent customer. So let's start with the private pilot. What is the private pilot complaining about today? What are his problems? What are his fears? Today, if he goes to fly in a very old aircraft, the one Dominique learned to fly on before even I was born, sorry, Dominique. There are still too many possible failures. If you look at those metallic aircraft, there are corrosion, there are fatigue, there are problems with the painting, with everything. And if you look at the more recent aircraft, which are black metal composite aircraft, you can always fear that there might be some bonding consistency problem. On the other side, as soon as the pilot gets on board this aircraft, he might be afraid that he can do some stupid mistake. How is it possible that today, in the 21st century, a pilot can still make mistake on the fuel tank? We have too many aircraft flying, falling or landing because of fuel tank starvation, whereas there is somewhere in the aircraft fuel, maybe even a full fuel tank. This kind of stupid mistake should never exist anymore. If now we look at the market from the flight school standpoint, there is simply on the market not any available aircraft, recent aircraft, able to do from the basic VFR training up to the advanced IFR training. It's simply impossible. And if on top of that you want this aircraft to be attractive, it's even more difficult. And of course, we can finish by the money matters, which is often an important matter, because of the very high unavailability rate of our aircraft, because the checks and maintenance are always too long, our aircraft are grounded for too long time. So overall, the cost is too expensive. However, unfortunately, we could say that we have to reduce the purchase price of the aircraft. But sadly, I have to say, and I think Sonaca and Pipistrel will agree with that, we have more or less all the same price, and it's a given price. We have the same engine, the same propeller, the same landing gear, the same avionics, and we are all building our aircraft in Europe. So how are we going to do that? How are we going to make, First, do we need more affordable and safer aircraft? Yes, the easy answer, and you all know that, is yes, we need that. But how are we going to do that? We simply have to reduce the operating cost as the purchase price is a given value for more or less all the aircraft production. And of course, we must keep on working on improving the safety. Well, I think by showing you that very nice picture of a very old Cessna, we all know more or less what to do to reduce the operating cost and improve the safety. We have to simplify the aircraft. Because today, if you look at a Cessna, for example, Cessna 152, which is two-seater like our aircraft, this aircraft is made of over 15,000 references, not parts, just references, without the fasteners. Too many parts, too many assembly, too many possible failures. Of course, this is a major problem for us. And if you go a little bit further and look at the maintenance of our aircraft, I think it gets even worse. Well, I had the opportunity to do a lot of maintenance since my very early childhood on over 60 aircraft. And for example, Dominique, have you already working on the fuel line of a Captain? You know quite well. Well, you don't have very difficult tasks, but they are always very long, and you have to do many tasks which are not relevant to the important task you have to do. Sometimes you have to remove the seat, the panel, both of them, just to change a filter. So you're creating possible problems which should not even happen. And here again, we have to reduce the complexity of the aircraft to reduce the maintenance time and cost. So how Elixir is doing that? Well, it's actually quite simple. We are reducing the complexity of the aircraft by reducing the number of parts. And to do that, we are introducing the Elixir, a very new aircraft, which we are currently certifying. We are probably the first to have asked for the new CS23 Amendment 5 certification. And our aircraft is made of only 600 references, including the fasteners. So to do that, we are introducing a technology which is called the one-shot. This technology has been used in the sailing and offshore racing boats for the last 15 years to go around the world in some very rough and difficult conditions. And it's very simple, actually. For example, we take one wing and we make it in one piece, in one part. One fuselage is one piece, one part. One aileron is one piece and one part. There are no more gluing, no more riveting, no more bonding. It's really a natural, structurally natural and simple parts. So if we look at the most impressive part of our aircraft, we can see here the wing. It's made in one shot. So it's an 8-meter long piece made in pre-preg carbon fiber with only one part. No glue, no rivet, no screw. So it's virtually, naturally perfect. And thanks to that strong innovation, we have been able to bring some more innovation on that aircraft to make sure that the customer will never hesitate to buy the Elixir. Thanks to the one-shot, we have been able to put one single fuel tank in the wing of our aircraft, which is explosion-proof and which do not need any fuel selector. And finally, it's located on the center of gravity of the aircraft. So as soon as you have started the aircraft, you will never have to switch or to take care about the position of the fuel in the aircraft. It has almost no incidence on the balance of your aircraft. And of course, so these two are the major innovation, but we have been working, yes, on the maintenance of the aircraft to make sure that you will never have to do an unrelated task to do a maintenance on your aircraft. For example, here we have a look at what's under our aircraft. You have two very wide hatches. One is giving access to the complete fuel system. And if you want to work on that fuel system, you have 4 screws to remove, and you can take the full fuel system on a drawer and to go and work on it away from the aircraft. On this drawer, you have the fuel pumps, all the filter, and the fuel distributor. Everything is in one part, in one place. Again, if you look at the aircraft from the engine parts, let's say you have a flight school operating 10 Elixir. If you want to change the engine of the aircraft because you have to do a maintenance or anything, you can change the engine of the aircraft in less than 2 hours. The complete engine. You take it off, you put another one, and less than 2 hours after, you can be flying again with the aircraft. We have obviously also been working on the inside of the aircraft. Here you can see the first prototype of the VFR panel version of the aircraft. So you can have both traditional and a full glass cockpit instrument that allows the pilot, when he's a young pilot, to be concentrated on only what's important, the basic instrument. And as soon as he moves on with his training, he can start to use the glass cockpit and etc., etc. Of course, you can see that you can also put an iPad in a very easy way. And whenever you don't use it, you can put it in the glove box, which is just under the instrument. It's simple, but useful. And because of that one-shot technology, we have been able to gain a lot of weight on the aircraft. The total final weight of the aircraft, ready to fly with all the instruments, all the system, which will be around 300 kilo. So we'll have more or less 300 kilo payload. But because this one-shot technology allows us to make a very light aircraft, we have been able to invest a lot of weight in everything that needs to be strong and rough for the lifetime of the aircraft. The best example is obviously the landing gear. We have a landing gear which might not look very innovating to you. It looks like the PA-28 or the AF400, but it has shown to be the most reliable and comfortable landing gear of the last decades. And of course, and I'm actually wondering why not many more aircraft have that, we are offering the parachute as a standard. Parachute is not an issue for your flight, it's not an exit, but everyone deserves a second chance. If you have engine failure over a forest, over a mountain, well, obviously you're able to put the parachute. Now that we made sure that the customer is sure to buy our aircraft, we can make sure that Elixir is going to earn money, is going to be a very sure company for the next decades, the decades to come. By having this one-shot technology, we are able to reduce the production time of the aircraft by at least 40%. That allows us to ensure the life of the aircraft and the life of the company for many years to come. And to conclude on that subject, the Elixir is simply the first of the new generation aircraft that will probably pioneer the aviation of tomorrow. So you may be wondering, what are the previous generation? So obviously, as said before, the first generation was made of wood and canvas. The second revolution was to bring metal in the aircraft. The latest one was to bring carbon. But in all of those generations of aircraft, the geometry, the structural geometry of the aircraft never changed. None of them have been able to pull the optimal capacity of the composite fiber. And at Elixir, we are using an aircraft with a wing that has no spar, no rivets, no ribs, because we are using the full capacity of the pre-preg carbon fiber. So that's all for the modern and affordable aircraft, and obviously safer. But I would like just to take 3 minutes more, I think I have, to highlight some subjects which seems important for Elixir for the future of general aviation. I would like to remind each and every one of you, even if you're probably aware of that, that certification is very important. When we started Elixir, we were wondering if we were to make an ultralight or certificated aircraft. And obviously, when we made the calculus, we realized that having a certified aircraft is so much cheaper than trying to have a microlight in every European country. So we went full on the certification. However, today, when you go on an air show, when you're talking with customers, people don't understand why we are certifying the aircraft. They don't understand the advantage of the certification. So here I asked the EASA, I think EASA needs today to have a real marketing and communication service. I think you all try your best today, the EASA team, but it's not your job and you cannot do that perfectly. So today, please try to invest some money, some time to make sure that journalists, paper, website, talk about your certification, talk about the advantage of the certification, because we, as an aircraft builder, need that from you. Another important subject here, and it's a difficult one actually. We have to congratulate some of the EASA experts working with us because they have been very efficient in giving us advice, in helping us. However, on the other side, some EASA experts have been very non-productive with us. And the point I would like to make here is that you can be lucky or you cannot be lucky on the EASA expert you are meeting. And the only thing I would like is that to make sure that we all have an equal treatment when it comes to certification. I'm not sure it's the case today. I'm almost done. And here a little subject to thank Pete Bunce for coming here today. When you are European, you're looking for statistics in Europe. Well, the only place you can find those statistics is on the American GAMA website. And I like America, but this is quite sad, and it's missing a lot of information. So we, as a builder, aircraft builder, we need to organize something. I know there were a project of European GAMA. I think we need to push that project forward and to build something together. And finally, a little subject on what has to be done to bring more young people to aviation. In France, we have, I think, a very good program, wide program, including a very young age pilot license, including some subvention, etc. I think this program needs to be pushed forward and probably generalized around Europe. That's all. Thank you very much.
Thank you, Arthur. I believe it's very refreshing to hear the message from the new generation, the fourth generation. Huh? And but now I believe we will close the first part of the discussion with Ivo. Ivo Boscarol, I'm sure that you all know Ivo. He is the CEO, founder of Pipistrel. He is an inspiring personality, passionate about GA, and he will tell us what he's thinking about, what we should do to make more modern, affordable aircraft. Thank you, Ivo.
When I was invited to have a speech about affordable aviation, I was asking myself, what means affordable for myself, like a pilot? I said, everything possible to do to satisfy my wish, my desire to fly. Yes, but when I started in '75, I was flying in a different country than Dominique, and making aviation, or let's say affordable aviation, afford to the aviation was not so easy. If you was not, let's say, dedicated, or if you was not, let's say, selected to go in the army, or like army pilot, was almost not possible to fly. So with some friends from France, from Italy, we started looking for a different way of flight. At that time, we call it alternative flight. Later, it gave the name, let's say, adopted was ultralight or microlight flight. At that time, this was very easy, you know, no regulations, no certifications, but the safety issue was almost the same like today. There were no safety standards for such machines. So we were forced to accept alternative standards, to make our own safety standards. But the approach to the aviation was almost the same. You know, going through legislation and survive with these strange flying machines. Unfortunately, a lot of my friends are not here anymore. I'm still here over 6,000 hours of flight in very strange machine, testing the aircraft, because I was lucky, but I was also always accepting alternative safety standards. And my goal was always to be legal. And believe me, in former Yugoslavia, was not easy to be legal with these strange machines. But, you know, for me, no wall is enough thick that my head would be not enough strong to go forward. And finally, I was able to get the certificate like a first aircraft producer in all Balkan area, and to have also first ultralight, or let's say trike, certified, because at that time in Yugoslavia was not alternative certification. It was just a type certified, and the first trike certified ever in the world was my Pipistrel. Since that, you know, as we were flying in very strange machines, I said myself, we must make the aviation efficient and affordable and safe also for the others. So I said, why we don't design the aircraft in a way that if the engine fail, what was very frequent at the time, safe even in sync, so it can land very safe, to reduce the noise, to reduce the consumption, to make it friendly, environment friendly. Also, the production, all these factors are very important on the end to make the aviation affordable to the people. In these 30 years of my professional career in aviation, we learned a lot. Today, during the lunch, we had a very interesting discussion how to motivate the producers of battery cells to change them in a way that will be, let's say, usable also for the aviation. It was constant fight, and it is still a fight, how to improve the safety, how to choose new materials. You know, when I started with glass fiber and carbon fiber, was not that it was not allowed. It was forbidden in aviation, you know, and going through these processes and motivating the authorities to accept new technologies was almost the same like today. Today, I must say that the authorities are much more flexible than at that time. But with all this ultralight and experimental class aircraft, we learned a lot and we were able to grow. Pipistrel is not anymore a garage producer. We have the productions all over the world. We are producing one aircraft per day. We have almost everything in-house, what is necessary to design, to produce, to test, and to be efficient. Because nowadays, you know, affordable aviation is really connected to efficiency. We have a lot of certificates all over the world. We are the only company having 4 certificates also in China. We are producing, as I said, one aircraft per day. And what we are very proud is that we made some milestones also in the history of electric or hybrid aviation. And also the future. The future, okay, these are some references because of our, let's say, work. But the future of aviation, we see really affordable for the final user. If you see the running costs of our certified aircraft, which was, by the way, the first in the category certified for night VFR intentional spins, and also the first in the category certified with 3D parts, means that we made a lot of progress, also motivating the authorities that the safety from the other standards can be applied in such an aircraft. What you see on the top in the center is the first dedicated serial production line in the world. It's nothing to compare with the affordability of electric aircraft to the piston engine or fuel-powered aircraft, because the parts are way less. The time to assemble it's only 170 hours. Pay attention. And the cost of the energy is way lower. So I strictly believe that the future is in electric aviation. We have a lot of challenges, I know, but Pipistrel focus is to offer tomorrow the affordability which is really written with the first A big, you know. Also, you probably know we were selected by Uber to develop with 4 other partners the so-called flying car. The problem of the atmosphere in big cities, in mega cities, is really big, believe me. I'm traveling a lot. And you see on the top of on the right, this tiny blue belt around our Earth from the space. That's our atmosphere. People can live months without the food. People can live weeks without the water, but only few minutes without the air. So it's our duty who can contribute to this, that our atmosphere and the aviation will be cleaner in the future, must work on this. We are designing a different type of our VTOL. We are designing a flying aircraft, which is, let's say, designed for cruise, not for vertical takeoff, but of course with the possibility of vertical takeoff, with dedicated propulsion, especially for electric propulsion. We are now in the phase of testing, data verification with the model. And of course, believe me, in future, the aviation will be electric. Or, okay, in some combination with hybrid fuel cells, maybe hydrogen fuel cells, hybrid in the meantime, but in future, electric propulsion will dominate. I'm convinced in this more than 20 years, you know, we are selling electric aircraft 11 years. The others are still talking. We are selling. We have the market experience of sale electric aircraft 11 years. In future, I'm quite sure aviation will change a lot. If you have kids, just go with them to the airport and take photo of the aircraft with the wings, because the wings will disappear. Slower or later, believe me, they will disappear. And we will also bring in future the airport to the customer, to the passenger. It will not be necessary to walk or to drive anymore to the airports. We are damaging, we are destroying the best land for the airports. This must be changed. And I'm quite sure all together with the regulators, we can reach this goal which we all desire, to offer really affordable aviation in the future. Thank you.
Thank you, Ivo. We are all dreaming now, huh? This is why I was the last speaker. I knew it would be something like that. Huh?
There is no progress without dreams.
True. So I believe we probably have some questions from the attendants. Okay. Who wants to? Bruno. First question. Certification standard far too high. Any idea on this one? No.
I'll just take a shot at that. I think what we're trying to do with CS23 is address that. And again, if we apply that risk-based approach that we've all been talking about, we have a capability in level 1 and level 2 to 4 seat, to really reduce the burden by using the consensus standards that we have developed with ASTM. And as we then get experience that you're able to I think benefit from, and we've got test cases going on both back in the US and here in Europe, we're going to be able to learn from that. Then we can apply it to what Ivo's talking about, because for these aircraft, if we apply those lessons learned for CS23, even though they have some vertical component of it, we might have to do special conditions into CS27, we will be able to make some rapid progress and drive certification costs down and time to market faster.
Any addition on this one? No. The next one is a bit difficult to understand from. Okay. There is no need to buy a new plane.
If I may. Well, yes, I can understand this question. The second-hand market is always the main competitor to the new products, at least for our class here, and the old airplanes are just good. That's why it's easier to sell into a training market where really the operating costs are a business case for them. And that's why we need to make the small airplanes cheaper, also not only in the operating cost, but also manufacturing costs to get competition with the second-hand market.
Yes, also now I see the question. And maybe I would like to add something, especially talking about the gliders here. True that if you have a look from outside, if you are not a glider expert, specialist like Janus, one of my colleagues, if you see a nicely maintained LS1 or Cyrus 75, so Cyrus 75 means was produced in 75. They are still looking very good. But since 75, we did a lot to improve the level of safety of gliders, especially in terms of crashworthiness. And you know that it happens, but when you are flying with a glider, you have to land outside a normal airfield. My best friend is a private pilot, was a glider pilot. The family, they are all flying. His wife, the two boys, they are now commercial pilots. And he was flying with one of these Cyrus 75. He had to land outside. And he got outside an airfield, got into a power line, crash, woke up in the hospital, alive, vertebrae broken, ankles totally destroyed by the known effect of this glider fuselage folding like an open banana. We know that this is a killer. This has been studied, addressed by the TÜV many years ago. Recommendations were made to the manufacturers. When I talked to him and I asked him, hey, Bernard, because now he's working with Ken, difficulties to walk, were you aware that the level of safety of your inexpensive old gliders were not the same than the modern gliders? He had no clue. No clue. No culture, no safety culture to properly address the difference between a modern glider, of course, more expensive, and this old glider. So this could be also the reason why people are not replacing this old machine, because there is maybe a lack of safety culture and understanding of safety level when you are flying with the machine. So just my thought. Next question, maybe. Yeah.
Yeah. Thank you, Dominique. Yes, that goes again with the communication point I made before. But I think this is an interesting question. It depends how we look at the question. Are we looking for aircraft for all pilots, the current pilots, or aircraft for the future pilots? Because today, for each and every one of us, we are happy to fly a Cessna 150, 152. There is no problem. But let's talk at the instructor or the flight school who needs to attract young pilots who are 15 years old, 16 years old. Do they want to fly in a Cessna 150 while they are using an iPhone at home? No, probably not. So yes, those aircraft are good enough, although the security, the safety may be improved. But if you want to have pilots tomorrow, you need new aircraft. It's as simple as that. Pete showed us before the number of production aircraft, the aircraft production. It's very simple. Since Cyrus aircraft exist, they have always been the first. Whereas Cessna 172 are still good. Market proves that they want and needs new aircraft. Pipistrel is here for almost 20 years. They have been building aircraft once a day, whereas Cessna does not even build anymore 150. The market needs more modern aircraft.
Thank you. The next question, maybe Bruno, we talk about your comment concerning lack of system integration and standardization. Maybe we can elaborate on that and see what we can do.
Yes, it's quite simple. If you remember the battle we had years ago with the standardization of the USB plug connector on all these mobile.
Can you please read the question first before you answer the question?
Okay. Pilatus representative mentioned about lack of system integration standards. How EASA and industry are working together to manage this? Again, the issue is trying to harmonize all connectors, all interfaces to the systems. Because the same issue you have at home with different plugs and different, on the USB, for instance, you get in an airplane. And it would be really recommendable now to get together and trying to set some standards to facilitate and standardize, modularize all these components. The issue is over the life cycle. As soon as you have to change some components, you will have to go through really a big burden to rewire the system. I know a company in the US, they do major upgrades also for airlines. They have to develop specific boxes to adapt to all the interfaces. And this is extra cost. So there is definitely synergies there if we get together and we start working such standards.
So to answer the question, there is nothing put in place actually at the moment to address the question, because it was, I believe it's a proposal and it's an information that is brought to us by Bruno today, but I believe it's an interesting topic that we will try to take on board in the context of our technology for safety activity. So we have the opportunity to take a question from the room with a microphone, but before that, I would like to take the last one, because Ivo would like to answer it. So EASA certified air sport aircraft are getting expensive. Are customers or the regulator responsible for ever increasing cost of design in crashworthiness? Ivo.
I believe here should be written light sport aircraft, not air sport aircraft. So who is responsible that EASA light sport aircraft certified are getting expensive? You know, affordability of the aircraft means also large production. So as much as you produce, better price you get from the suppliers, everything can be optimized. Unfortunately, now today EASA is really future-oriented, but unfortunately in past EASA made one big mistake, one failure. The category which is known in the other part of the world like light sport aircraft got the same name in Europe for the certified aircraft. And because of this, we all European producers, we face problems justifying that our aircraft is different than from the others. You know, in US, LSA category allow night flight, PPL training, no medical, and the aircraft is not type certified. We have very limited market. We can sell in EASA member states, but our competitors from the other part of the world, which are selling the same name aircraft and which has also the same, let's say, possibility to use, make our aircraft expensive, because the number should be or could be much higher. We must all understand this.
Thank you. So, if there are questions from the room which are not in Slido, and that would have, you can use the microphone to ask the question. If we have nothing from the room, we still have a bit of time to continue with Slido. Yes.
One issue that I see here, and I don't know that I should bring it up because I'm cutting my own market, but the authorities say by the rules what must be done to certify an aircraft. And the people I talk to, my customers, come to me and say, how do we do that? And I think there's a dilemma there. The authority should not say normally how, because the means of compliance is selective of the applicant. Nevertheless, I think that it is an area that is a gray area between the what and the how that one way or another should address. And if we talk about system integration, there is a protection of certain manufacturers that want to keep their systems together and not so much communicate with other systems, because then they are opening the market to their products. I think there is a challenge for the aviation industry to talk about the integration of the what and the how.
Dominique, thank you for this question, and it is very close to it would have been close to the following questions we had. The biggest issue we have as OEMs, and I see all of us, we are in the same boat, independently from the size of aircraft we produce, is that in the last years there has been a huge consolidation of suppliers. I make a small example, European example, a small display company, Belgium, Barco. I was buying from Barco, then suddenly was acquired by a Canadian company, Esterline, CMC, and last month I was told it has been acquired now by Transdigm, an American giant who is buying all these small OEMs, and what he's doing is swapping the management and asking for a 2-digit margin at the end of the year, and so you survive. So what happened to us, and I'm including also the big player, including Airbus as well, we are not anymore on a 2-digit margin. Our suppliers are. They're getting fatter and fatter. We are struggling, all here us, trying to really look at the last optimization to get the minimum margin you need in order to sustain development. And this is really a big issue. We are dealing, I have a 2,000 people company with already 1 billion. I'm dealing with my suppliers with have at least 10 times, 50 times bigger than I am. And this will be the big issue in the future. Who is controlling the pricing? Who is controlling the competition? Is the OEMs, us, or our suppliers? And I feel that we are in the sandwich between the suppliers and the customers.
So let me just give you a little different perspective, because I represent OEMs and suppliers. We're all in a free market economy. So now you take a supplier and you look at the current tariff battle, especially between China and the United States right now. Most semiconductors in the world are produced in China. The price has gone up about 25%. But most of the suppliers, and that's why, and I'm only saying this just to show you the complexity of the marketplace, most of the suppliers have fixed price contracts with the OEMs. So they sit there and they say, okay, my price from the Chinese is just because of the tariffs has gone up 25%, but I can't pass that on to my OEM until I negotiate a new contract for perhaps new aircraft out there, and we don't have enough production out there to make the ecosystem flow right. So from a supplier standpoint, they sit out there and they feel like they're at the end of the chain. So now you do have these consolidations. You also have the consolidations at the OEMs as well. That puts more perturbation in the system. So I think there was a question, I think Martin asked it later on, you know, if we go and have this new system, CS23, FAR23, will the OEMs be able to pass the price on to the customer? It's so dependent upon what's happening within the whole ecosystem of aviation together. But if we could ever get economies of scale, if we could get electric and hybrid propulsion going, and we will drive down the cost, especially of avionics, but also how we build things, carbon fiber, but also with using additive manufacturing on aluminum for structures right now, we're driving down the number of parts in the new GE engine that's being built. I think it's on the Cessna Denali. They've gone on, just in that engine itself, they've reduced the number of parts from 2,000 down to about 1,020 or so in certain very hot sections of the engine. So that's going to drive down price as well. So it's a very complex ecosystem.
Yes, but just to finish, in the last couple of months, I had a couple of suppliers who came to me and doubled the price on a take or leave it basis. The contract is irrelevant. And you are blackmailed because the production has to continue, and you know that to look for another suppliers and search for another equipment, it takes 2 years. So you have 2 years' times where you are under threat and you have to pay whatever it asks you. Otherwise, your production stops. Now, how can you avoid it? And this is why I'm coming back. If I would have more standardization in the systems, I could go shopping and get another systems and be sure that within probably 6 months I am out of this trap. But unfortunately, I've seen that there is no ethic anymore left, and every second week I really don't look forward to this telephone of the suppliers, which is basically says, I cannot do it with this price, so sorry, I have to double it.
Maybe a last word from Ivo, and then it will time to stop this interesting session.
You mentioned electric and hybrid propulsion, that the prices will go down. I'm not really sure, because we face another problem, that the electronic component suppliers don't even talk with us if we don't need 10,000 units or 5,000 units. It's not possible to buy a small single screen if you don't order 20,000. You know, so that's another part of the story. Electric aviation can be, let's say, more affordable, but the suppliers will be bigger challenge than in classic aviation.
If I would just add, Ivo, and that's an excellent point. So our representative from Bosch was just in China. I came from Changsha, and he made that point that as we make this revolution to use this new technology, if we do not leverage off of the automotive industry, and you look at the amount of components they put out there, so their way of certifying is, well, they don't certify in the same mindset that we have, but they certify by putting hundreds and thousands of kits out there that work very reliably. So if we don't leverage off of the automotive industry and what they're doing, especially in electric and hybrid, but also autonomous and using all of these sensors technology, then we just shoot ourselves. And so we collectively have to work with the regulators together as an industry to be able to leverage off of what we're learning in the automotive industry.
Thank you. I'm afraid we have to stop the discussion here. It's quite open. We cannot really close the topic. We have no magic solution to cut the cost down, but there are ideas that were shared, and there is at least a discussion. And I believe we need to create a forum so that we can continue to elaborate on this topic, because the question of affordability for the flying clubs, for the new owner, if we want to increase the level of safety, is a key element. So we certainly need to take it on board and find a solution. So we have a coffee break, and we continue with panel 3 after. So thank you, and see you back in 30 minutes. Yes, thank you.